Hello everyone, welcome to our channel 2 Bits. Those who are new to this channel, let me tell you that this is the third video on the Linkedlist series, and in this video we will discuss a medium level question, that is, remove nth node from the end of the list. Now in this question we are given a head and we are given a value n, that is the node to be deleted from the end of the list. For example, here we have a value 2, that is we need to delete the second node from the end of the list and return this particular output. Now for deleting the node 4, what we actually need to do is we need to break this link and make 3 point to 5 instead. So this link will be broken and 3 will point to 5 as we need in our output. So for breaking this link, we need to reach 3, and suppose this particular node is temp. So what we need to do is we need to break the link temp.next, which is currently pointing to 4. So temp.next is right now this link. So we need to break this and make temp.next point to temp.next dot next. So temp.next, this link is right now not broken, so temp.next is 4 and 4.next is 5. So we break this link and make 3 point to 5. Now let's see the first solution that you will be telling in an interview. Now we know that we need to delete the second node from the end of the list. Now let's say that this is the length of the linked list. So let's say the length of the linked list is k, which is equals to 5 here. And here we know that n is equals to 2. This particular node, as we need to reach this node, so this node will obviously be k minus n, which is 5 minus 2, that is the third node from the start. So now we know how to reach this node, and we already know how to break this link and point 3 to 5. So this is the first solution that you will be telling in an interview. Now let's see what is the time complexity for this particular solution. So what we are doing is, first we are finding the length of the linked list, as we are only given the head and the value n. So we need to traverse the complete list to find the length of the linked list. So suppose here the length was k, so it will take order of k. Now we are again traversing the list the second time to reach n plus 1th node, as we need to break the link. So we are again traversing, and there can be a case that we need to delete the last node. We will need to traverse the whole list again to reach the n plus 1th node. So it will take another order of k time. So basically we are traversing the list twice. So this is a time complexity, and we are not using any extra space, so space will be constant. Now there can be an edge case in which, suppose you need to delete the first node, that is the fifth node from the end will be the first node. So if the length of the linked list, that is k, is equal to n, then that means you need to delete the first node. This is the head, so you will simply return head.next, as head.next will be this node, and you simply need to return this node as we need to delete the first node. So this will be the edge case. Now let's move on to the optimized solution. Now, as we have discussed, in order to delete the nth node from the end, we need to reach the n plus 1th node and break that link. Suppose we have two pointers, a fast pointer and a slow pointer. We have a fast pointer and a slow pointer that is pointing to head currently. Now what we do is we first make the fast pointer move n steps forward. So here n is 2, so we make fast move 2 steps forward. Now we can see that the slow pointer is at a difference of n from the fast pointer. So now we move forward slow and fast by 1 step each till fast reaches the last node. So let's see. Now we move fast by 1 step forward, and in the same iteration we move s 1 step forward. Again we move fast 1 step forward, and we move S one step forward. Now we see that fast has reached the last node, as the last node will have no other node after that. So the next of the last node is null. So now we need to stop here. Now we see that the difference here is n, and if the difference is n, then that is the n plus 1th node. Slow is pointing to the n plus 1th node that we wanted to reach. The slow and fast pointer are a difference of n. Then if fast reaches the last node, slow will always be pointing to the n plus 1th node that we wanted to reach. Now what we simply do is we break this link and make s dot next equals to s dot next dot next that we did before. So we break this link and make the slow pointer point to 5. Now these are the steps that we have discussed till now. Now let's see if the solution work when n is equals to 5. That is, we need to delete the fifth node from the end, which is the first node. Now we need to delete the first node. Now let's see if this works or not. So we have two pointers, fast and slow. So first we did the first step and made them point to head. Then we move f by n steps. So here we need to move f by 5 steps. So after moving the fast pointer forward by n steps, we see that the fast pointer has already reached null. So if that is the case, that the fast pointer reached null after the second step, then that means we need to delete the first node, that is the fifth node from the end. So we will add one more condition here after the second step, that if fast is already equals to null, then we will simply return. Then we no longer need the first node and we will simply return this node, that is head.next. In this case also we only need to travel the list once. So in any case we are only traversing the linked list once. So the time complexity for this particular solution is order of n, and we are only traversing the list one, and we are not using any extra space, so the space complexity is constant. Now let's see the proper Python code for this particular solution. Now as we have discussed, our first step was to point fast and slow pointer to the head, and then we moved the fast pointer by n step. So in Python, when you write in range n, it does not include the last value. It always go from 0 to n minus 1. Now after moving the fast pointer by n step, if the fast pointer reaches the null, then that means we need to delete the first node and we simply return head.next. Otherwise we move the fast pointer by one step and the slow pointer by one step till the fast pointer does not reach the end of the list. And after that, we know that the slow pointer will always point to the n plus 1th node from the end. And we simply break the link and make it point to the next node. And then in the end, we return the head of the new list. So this was our Python solution. Link for the C++ solution is given in the description, and the link to join our Telegram channel for important updates is also given in the description. Please check that out. Thank you for watching. If you liked the video, then please like, share and subscribe to our channel, as it motivates us to create more such content for you.